Welcome everybody to this year's, the whole ICFP week, but in particular to the Haskell Implementers workshop this year. I'm Josef Svenningsson, and I've been making sure that this is going to happen this year. So I just want to say a few brief things about today's program. We have 11 excellent talks, and they were selected among a few more submitted abstracts. As you will see in the program, we run a little longer than the other workshops, and that is to make sure that we have time for the lightning talks that is usual at the Haskell Implementers meeting. The program that we're given this year was a little bit more crammed, and so we decided to extend the time a little bit. So in case you wonder, that's the reason. I want to say a big thank you to the program committee who helped put together the program that we have this year. So thank you for that. As for the lightning talks, you want to give a lightning talk. This is a great opportunity to show off some simple idea that you have or some work in progress. And we have this 1-hour session at the end of the day where you can give this. In order to sign up, talk to the session chair, Alejandro Russo. Alejandro, this is the guy you want to talk to, and he will set everything up. So just go and talk to him. And it's first come, first serve, so make sure you talk to him as soon as possible during the break. You don't have to do it right now. But, and then we'll try to do, or they should be 5 minutes, so we'll try to fit in 12 talks if possible during the final hour session. All right? And now, he shall from time to time give to the community information of the State of GHC, JS, and recommend to their consideration such measures as he shall judge necessary and expedient. May I introduce as the first speaker, Simon Peyton-Jones.
Well, friends, nice to see you all. This is very exciting for me. I'm allowed out to a special dispensation for 1 week. Which doesn't have to be very much these days. This is a quick, this worked 5 minutes ago, so a bit of luck does it work, but no, it worked. consultation with Demetrius, and I've done this very nice new exhaustiveness checker. So that as GHC's pattern matching exhaustiveness checker forever, for nearly 2 decades, I've been saying it was really just run up by a PhD student in a wet Sunday afternoon, and it needs fixing. And finally, George has fixed it. And to account for GATs, which I didn't really know how to do until we started doing this work, we found a very nice other way to do ICFP paper. So come to that talk at ICFP. Jan, is Jan here? Jan, yes, he's here. So we've had these type family things, but when you do type inference on type families, you find that you sometimes get a failure of type inferences. I can't prove that f of a is equal to f of a prime. And you think, it's not very hard, just make a equal to a. But that's only sound, because it's only sort of guess avoided if f is injected. So Jan is allowed to make it possible to declare type functions being injected, check that they're injected, and then exploit that during type inference. So this, as it were, gets us a bit closer to what functional dependencies have always been able to do. Simon, like last night, checked in sort of what I hope is the final version of the Implicit do patch. He had the sort of, this is do notation which lets you generate applicatives rather than monads. He had a first version that I couldn't understand at all, so we had a long sort of head back session. And now I think there's a great chance of my understanding, which is there's a sort of very high bar to getting into GHC, which is you have to persuade me that I can understand it. And since my level of understanding is quite low, it's quite difficult to do. But he's almost succeeded here. Implicit, I'm going to say a little bit more about this call stack thing in a second. Johan and is Adam here? He's not here. So we're doing strict Haskell. So you can sort of add a flag, and suddenly all function calls become strict, and a different flag, and all data structures become strict. Why you want to do this, I can't think, but they're
That's exactly why.
yeah, exactly. I'm going to say a little bit more about overloaded record fields in a sec. Now, here are some big ones. Kind equalities and GATs at the type level. This is, you'll have seen previous ICFP papers about that. Richard Eisenberg is the sort of supreme being of this. It's been a long time coming. It's taken a long time to persuade me that I can understand it. And even so, it's a bit, but he's been working at it for so long that I feel embarrassed to admit that I still can't understand it. But finally, I've come across a reason that I really want it, which is type index type representation. So now I have a powerful motivation just says you took the head of the empty list. You think, come on guys, where did I take the head of the empty list? In what function? Well, one thing that Haskell programs often resort to, I have resorted to this myself on occasion, is just to add an extra parameter to head or to the failing function. And at every call site, I have passed an extra little argument. So now I can tell among the various call sites which of them are. Oh, so I have to alter the type of the function, and I have to find all its call sites and add strings. And then, that's painful enough. Then what if Fugle turns out to be called from a lot of places? Oh, this is depressing. When you do this, you start to feel this language is not supporting me as a programmer in the way that it should be. So here's the idea of that. Very nice little simple idea. We've explored a lot of variants of this idea before, but this is the one that we've ended up because it's so simple. So here it is. You give head an extra implicit parameter constraint, right? So, and what you call it, CS here, doesn't matter. The important thing is that here it's got the type call stack, which is a new magic type the GHC knows about. So of course it doesn't take an explicit argument, because implicit parameters aren't explicit arguments, they are implicit arguments. But of course you can refer to CS in the body, right? And call stack is an implement of as an instance of show, well, or there's a function show call stack. So now what happens? At the call site, therefore, right, if we call head, we're going to need to come up with a binding for implicit parameter CS of type call stack. Well, Fugle didn't have one. But so the only magic is that this particular implicit parameter with this particular built-in type, if there's no way to generate it from the context, it's simply generated from the call site. So at the call site, GHC just says, oh, at this call site, since I need something of this type, I'm going to stick on a, here we are, head, this bit, called out foo 10.9 in main.foo. It'll stick that on the front of that implicit parameter right here at call site. So in effect, it's just automating this little string generation, but adding a little bit it's a bit more structure, because call stacks have a little bit of structure. See, that's just very nice and simple. And if Fugle had type into something, then that's all that would happen. But if Fugle itself, if you manually give Fugle itself a call stack implicit parameter, then at this point, we'll just push on the stack the extra, we'll take the arguments passed, add to it the call stack here. So in effect, we're building up a little part type, or a little sort of explicitly passed stack patches. Okay. And the nice thing is that it's sort of incremental. It only happens if you ask for it. So we'll never infer this kind of type. And what I'm really happy about as an implementer is there is literally zero impact on optimization or transformation, anything, code generation. Nothing changes. Unlike Peter's stuff, for doing stack map tracing with dwarfs, which has some quite basic impacts. This is very, very honest. And of course, it's very programmer understandable. There's no nonsense about you have to understand about lazy evaluation. The semantics of this is easy. Okay, so I really can't think about that feature, which I hope will be useful to you. So you're not looking terribly happy. Overloaded record field. So this is probably the single deepest swamp. Or maybe it's not very deep, it's very, very wide swamp. I can't find a pound for every hour I've spent reading about or thinking about or responding to email about records in Haskell. And sort of various, I've written more than one paper about various record systems in Haskell. Many other people produce libraries or papers about it. It's a very big design space. So in the end, since it's so embarrassing to have these sort of somewhat limited records in Haskell at the moment, we've kind of finally plumbed for a pretty simple modular design that doesn't do everything, but what it does quite well. So here it is very briefly. There are three individual pieces. One is just the ability to allow duplicate record field labels. I'll say a bit more about each of these things, but just there are three separate pieces. That's what I want you to get a hold of. It's not one big complicated feature. It's three separate features which fit together nicely. So here's feature number one, duplicate record fields. So with the patch that Adam has ready to go, you can just declare duplicate record fields. So here, T and S both have a field called X, which apparently is in. Well, so what goes wrong? Well, various things don't go wrong. So in particular, construction and pattern matching. Here's construction and here's pattern matching. No big deal, right? You're saying look T. Of course you need the X for look T. This X, not that X. Right? There's no ambiguity at all here. So construction and pattern So at the moment, in GHC, or in Haskell as she is born, X is a record selector. You say X has type T to int. Right, well here we have type T to bool. So maybe there are two record selectors called X. So that's the bit that changes. That if you try to use X as a variable, right, as a record selector, in the presence of both of these, GHC will simply tell you that it's ambiguous. Right? So then you might say, well, how can I do record selection? Well, of course, one way is just to do pattern matching, right? We'll come back to overloaded record selection in a second. But notice that even with this, it still may be useful let's see, if there's only one X in scope, then you can use it as a record selector. So the record selector still exists, right? They just, so here, there's only one that you could possibly mean, namely, the one that you got when you imported T, because I imported T here, but not S. Does that make sense? So the only thing that stops you using X as a record selector is the fact that we don't know which one you mean. Okay? So that's feature, that's number one, which is useful all by itself. Right. Number two is a variant of sort of type classy stuff that we've discussed a lot over the years. So here's the particular rendition. We have a class has field. I'm going to abbreviate. I'm leaving out updates for the moment, but I'm just doing the simplest possible version. Has field has two parameters. X, which is a symbol, that is so here's an instance. Might be easier to look at the instance. So the T data type has a field X, and the type of the field X is int, and the get field, which is the record selector, is just the record selector. Does that make sense? So so this is the declaration of the class, this is the instance, and this instance is sort of auto-generated for every data type declaration. In the implementation, it's not actually auto-generated, you just sort of do it on the fly in the script. Okay? So that's pretty simple, but it's a bit inconvenient to use this overloaded record selector, because look what you have to do. If you want to take F with type T to int, you have to say, get field, and then, what do I have to do to get field? Sadly here I have to give it this proxy argument, because the result type is, it doesn't tell me what X is. You have to say, essentially, which field do I want to get? So say, get field applied to proxy X and R. And you can do this. It's a whole standalone little feature all by its own. You can say this. It's just a bit inconvenient to do overload record selection. Okay. But at least the bit that's built in is the class is provided in the library, and the instances come for free. Right? They're implemented by the department.
Second one question.
Yeah.
Why isn't there proxy hash?
Proxy hash rather than proxy, I don't know, and it may not be in the end. I just copied that out of the wiki page. I'm not sure of the. Yeah, we'll have to see what. I probably should actually proxy this using this. Okay. Yes.
So if we have visible type application, and this gets a whole lot.
Yes. Then you could use get field, and you could say you could have a visible type apply here, and that might be a thing to do if we had.
Do we any to wait for that?
No. I think this is I think this is probably since this isn't in at all at the moment. Okay, right. It's not. There'd be even if it probably makes sense to combine the two. Yeah. Okay. Last piece is overloaded labels. Again, I'm not quite sure what to call this. So this is another orthogonal feature, which is a new built-in class called isLabel, which is a bit like implicit parameters, which again has a symbol argument and a type argument. It has a single method called fromLabel here. So what does this mean? The easiest way to see what this class is going to do is to see what. Beg your pardon. Sorry. The one built-in piece is that when you say hash X, you get from label type applied to X, right? So it saves you the visible type application. This is by close analogy with implicit parameters. When you say question mark X, what you actually get is something very similar for the implicit parameter class. So it's very, very close in implementation. So, but let me show you what the instance for isLabel looks like. It has a function instance, right? So if you use hash X applied to a record, well then, clearly, since this expands to from label of something, that's what the this is also very close to fruition. Adam Gundry has been working on this for quite a while. Yes.
The orphan instances.
For
Well,
his label,
yeah.
this is the only instance. Well, I suppose it is an orphan because Arrow is not. Oh no, I mean. Oh, that's right. I see. Yes.
If you want hashtags if someone wants hashtags to be a record selector, someone wants hashtags to be a license.
Yeah.
And then someone imports both of those.
Yes. Now
we have.
so that's right. So if your lens is a data type lens, right? Then you're good, right? Yeah. But there are very good reasons why everybody really wants lenses to be actual good on function outputs. And now you are going to have them. So I suspect we are going to end up with something to do with all. You can't use them both ways at the same time. Yeah. Otherwise, you can see it'd be hard to say. Right? Do you need the lens or do you need the arrow? The lens. Right. Do you really need to do the new type addressing numbers? You want to use the hash extension. Or maybe it lets become so important have some other syntax. Or maybe we just do get fields. Okay. So I was going to say a bit about type reflection, which I'm quite excited about because it uses type index this and that, but I'm conscious that we're close to half past, so I'm not going to. I just want to, because I want to spend a bit of while. Two. 10. Well, but I want to have a bit of have a bit of sort of open discussion. I want to just say, well, we can go back to type reflection if you want to talk about that, but let me just make sure we get to this. Right, so this is the same slide that I put up last year, except that we're coming towards 10,000, and now we've reached the 10,000 ticket barrier. So now I have to type it in longer. In my Firefox tabs, I can no longer see the whole ticket now. Use a smaller font or something. So, but the general story is just 10 to the 4. I'm delighted to see so many of you in the book today, because increasingly I spend my time sort of reviewing patches and advising people about making changes to GHC. Well, I'm doing it myself. The same very much true for Austin and Ben. Ben. This should be Ben Gabari, of course. Ben Gabari. That's right. No more Gabari. Ben, you're not here. So Ben and Austin are now working together on GHC support. But what I want you to remember is that their role is not so much to do lots of stuff, but to help you do it, right? Because there's this big community and a compiler with this kind of enormous surface area of stuff to do, and it's no good waiting for Austin and Ben just to do everything. They're only human beings, right? So, but it's fantastic and rather encouraging how many people have joined in to do quite substantial things to GHC these days. So really, I want you to think of it as your compiler, not Simon's compiler, and I'm just going to sort of do code reviewing and try to to help and advise and explain how the existing thing works and try to keep it all safe. That's the goal. So please feel sort of empowered and enjoy doing stuff not only to GHC itself but also to the Haskell ecosystem. It only works because of all of you are doing all this stuff. Okay, so last year I thought it was quite helpful to spend a few minutes just saying where are the pain points? What would you kind of like to happen at GHC? Whether or not you're prepared to do them, but just things where you think you need waiting for something, or think something's important but not very much people is paying attention to or stuff like that. What should we as a community be doing to this compiler? You can That's exactly what